Have you ever stopped to think about how the apps on your phone just seem to, well, know what to do? You tap a button and it just works. Today, we're going to pull back the curtain on one of the most powerful ideas in all of programming, how we teach a computer to make a choice. Let's dive in. I mean, really think about it. Every single time you like a photo or add something to your shopping cart or pick a dialogue option in a video game, the software is making a decision. It's choosing to follow one set of instructions and completely ignore another. That amazing yet simple concept is what we call branching.
So here's our game plan. We'll start with what branching actually is, then we'll look at the most basic decision, the if-then. After that, we'll add an alternative with else. We'll see it all in action and then wrap up with why this one little idea is such a huge deal.
Okay, first up, what is branching? The easiest way to think about it is this. Instead of just giving a computer a straight to-do list, branching gives it a fork in the road. It's that moment where our code gets to pause, look at the situation, and actually make a choice. Now, the official definition sounds a little technical, talking about a condition, but let's just cut through the jargon. All a condition really is a simple yes or no question. If the answer is yes, the code goes down one path. If the answer is no, it goes down another. That's it. It's a choice.
Programmers have a really great way of visualizing these choices using something called a flowchart, just like this one. See that diamond shape? That's the most important part. That diamond represents the crossroads, the exact spot where the program asks its question and decides, okay, do I go left or do I go right?
All right, let's build our very first decision. The absolute bedrock, the foundation of all branching, is a super simple statement. If, then. This is the first tool you get that makes your code start to feel, well, intelligent.
At the very heart of this if statement is the question itself, and it's built from three really simple parts. First, you have a variable, something like a student's score, which we'll just call x. Second, you have a comparison operator. That's the rule, like is it greater than or equal to? And third, you have a value to compare it against, like the passing grade of 50. Put them all together and you get your question. Is x greater than or equal to 50?
And here we can see exactly how that plays out. The code on the left is pretty straightforward. If the score is 50 or more, then print a success message. And the flowchart on the right shows it perfectly. If the answer to our question is yes, we follow the path to the success message. But look closely. What happens if the answer is no? If the student got a 49? With just if, then, the program does, well, nothing. It just skips that step and moves on. And that brings us to a pretty big problem, doesn't it? I mean, a program that only knows how to handle success isn't all that useful in the real world. What happens if the student fails? What do we do when the answer is no? We need a plan B. We need an alternative path.
And to solve this, we introduce one simple but incredibly powerful new word, else. The if-then part works just like before. That code runs if the condition is true. But now we can add an else block, and this second chunk of code will only run if the condition is false. It's the crucial second path our program was missing. And would you look at that? Our student score example is now complete. The code says, if x is greater than 50, then show pass, else show fail. And the flowchart makes it crystal clear. Our little diamond now has two exits, a yes path for passing and a no path for failing. Now we're talking. Every single possibility is handled. Okay, so checking test scores is one thing, but the real beauty of this if-then-else structure is just how flexible it is. So let's use the exact same logic to solve a totally different kind of puzzle. In this case, the program's job is to figure out if a number is even or odd, but the logic is identical. It asks a question in the if statement. Is this number perfectly divisible by 2? If the answer is yes, it goes down one path and prints even, and if the answer is no, it follows that else path and prints odd. Same structure, different problem. Now, you probably saw that weird word mod in the code and wondered what that's all about. Well, mod, or the modulo operator, is a really neat little math trick. It just gives you the remainder of a division. For example, 10 divided by 3 is 3 with a remainder of 1. So 10 mod 3 equals 1. Simple, right? So when our code asks n mod 2 equals 0, it's really asking, if I divide the number n by 2, is there 0 left over? And if the answer is yes, we know for a fact that number has to be even. So we've seen how this simple structure can handle grades and tell us if a number is even or odd. We've gone from a simple question to a truly versatile tool. But let's zoom out. What's the big picture here?
Why is this simple idea of choice so unbelievably important? Here it is. This is the big idea. That simple if-then-else logic we just learned, it is the microscopic, fundamental building block of practically all modern software. The algorithm that suggests what movie you should watch next, the enemy in a video game that decides to attack you, the banking app that lets you log in, it's all built on a massive foundation of millions and millions of these tiny little decisions, all firing off every single second.
So we've seen how this basic structure gives code the power to choose, and how that makes our technology feel smart and responsive. It all comes back to this one simple concept. So, I guess the only question left is this. Now that you know how code makes a choice, what's the very first decision you're going to teach it to make?